Welcome students. Today we discuss about the chromatography and the types of chromatography. First we see the introductions of chromatography. Introduction. Chromatography was first invented by M. Switch. In 1906, he was successful in doing the separations of chlorophyll and xanthophyll. The chromatography defined as separating a mixture of components into individual components is called chromatography. Next we see the definition. The chromatography is the mixture of separations of mixtures into individual components using the mobile phase and stationary phase. Classification of chromatographic technique. There are two types. One is partition chromatography, second one is adsorption chromatography. The classification of chromatography technique we see before you see the types of chromatography. The types we classified into three. First one is based on the nature of stationary and mobile phase. Second one is based on the principle of separation. Third type based on the modes of chromatography. The first type based on the nature of stationary and mobile phase is classified into three. Gas solid chromatography, gas liquid chromatography, solid liquid chromatography. The solid liquid chromatography example are TLC, HPLC, column chromatography, and liquid chromatography. The four types are included in the first type based on the nature of stationary and mobile phase. The second type based on the principle of separations that are divided into two, that is adsorption and chromatography and partition chromatography. It is the type of two based on the principles of chromatography. In adsorption chromatography, types is TLC, HPLC, column chromatography, gas solid liquid chromatography. Second one, partition chromatography. Third type based on the modes of chromatography, they are classified into two: normal phase chromatography and reverse phase chromatography. Now define normal phase chromatography means in this chromatography the stationary phase is polar and the mobile phase is non-polar. That is called normal phase chromatography. Second type, reverse phase chromatography. That means the stationary phase is non-polar, mobile phase is polar. This is wild in pharmaceutical analysis. These are the types of chromatography. Now see the classification of chromatography techniques is two types: the partition chromatography and the adsorption chromatography. Now see the definitions of partition chromatography and adsorption chromatography. First we see the adsorption chromatography. What is meant by the adsorption chromatography means the solid stationary phase and the liquid or gas mobile phase are used in this adsorption chromatography. Solute is absorbed on the surface of stationary phase. The more strongly it is absorbed and the slower it travels through the column. That is called the adsorption chromatography. Second one, partition chromatography. Partition chromatography means when two immiscible liquids are present in the mixture of solute will be distributed according to this partition coefficient when the mixture of compound are dissolved in mobile phase and pass through the column of liquid stationary phase. That is called the partition chromatography. This is a picture of the adsorption and partition chromatography. First, the type of the chromatography technique process means first type is the paper chromatography. Now we see the first chromatography, paper chromatography. Paper chromatography means it is separations technique in which the mixture of components can be separated into individual compounds between the stationary and mobile phase by using the specialized filter paper. We use the separation for filter paper. In this paper chromatography, the Waltzman paper is mainly used. Next we see the principles of paper chromatography. The chromatography that use paper sheets or strips as absorbent being the stationary phase through which a solution is made to pass is called the paper chromatography. The principle involved on the partition and Partition or adsorption chromatography. The partition chromatography because the substance are partitioned or distributed between liquid phase. This technique is the type of the partition chromatography in which the substance are distributed between two liquids. One is the tertiary phase, which is held in the fiber of the paper and called the tertiary phase, and the other is the moving liquid or developing solvents, and it is called the mobile phase. The components of the mixture to be separated are different rates and appear as spot at different points on the paper. This is the principles of the paper chromatography. This is the picture of the paper chromatography. In this structure, in this process we do the paper chromatography. The paper is used, nest solvent and lead is used. In paper, we contain the origin, red, purple, blue solvent front. These are parts of the paper chromatography. Next we see the procedure of the paper chromatography. First we select the suitable type of development, and second we select suitable filter paper, and third prepare the sample, and fourth spot the sample on the paper, and fifth chromatogram develop. The paper is drying and Carmo detergent is given. The detailed procedure of the paper chromatography means first we choose the paper chromatography technique. Before carrying the chromatography process, the method of paper chromatography technique will that is ascending or descending, radial or two-dimensionally selected according to nature of substance to be separated. Second, we choose paper stationary space. Chromatographic paper contain alpha cellulose, beta cellulose. Remaining is inorganic and volatile matter. The Wattsman filter paper of different grades like number 1, 2, 3, 4, 17, 20 mm can be used. The choice of filter paper depends upon thickness, flow rate, purity, etc. Third point, application of sample spot. Then we spot the sample on the paper. The sample is dissolved in mobile phase. Diluted solution of sample is applied on the filter paper with the help of capillary or micro syringe. Sample is applied as a small spot and overloading is avoided. If overloading occurs, sample becomes spreaded and slugged after development. So, the sample is applied as a small spot. Fourth point, mobile phase. The poor solvents, buffer solutions or mixtures of solvents can be used. Fifth one, paper development techniques. There are many techniques. First technique is ascending paper development. Second technique, descending paper technique. This ascending paper development means the solvent flows against gravity because of capillary action. Second technique, descending paper development. The solvent flows to the gravity top to bottom. Third technique, ascending descending paper development. It is the combination of ascending and descending technique. It is used to increase the length of separation. A long paper is used in the paper chromatography. Fourth one, circular or radial or horizontal paper develop. We can use circular filter paper and petri dish in this method. Fifth one, two-dimensional paper development. We can dip paper 2 times in mobile phase. That is called two-dimensional paper development. These are the techniques we used in the paper chromatography process. Next we see the advantages. Advantages is it requires very less quantitative material. Very less quantitative materials are used in the paper chromatography. Needs small space for setup installation. Needs small space only. Very convenient to use. More efficient for polar and water soluble compounds. Both unknown inorganic and organic compounds can be identified by paper chromatography. What are the disadvantages of paper chromatography means? Cannot be used to separate volatile substance. Second one, cannot separate complex mixtures and very less accuracy. Now it is non-effective. What are the application of paper chromatography means? First one, to check the impurity, to check the purity of pharmaceuticals. Second one, to detect alterants. Third one, to detect contaminants in drinks and food products. Fourth application is to determine dopes and drugs in human and animals. These are the advantage, disadvantage, procedure, principle, applications of the paper chromatography. Second type of chromatography is thin layer chromatography. First we see the definition and introduction about the thin layer chromatography. TLC means thin layer chromatography. What is meant by thin layer chromatography means it can be defined as the method of separation or identification of mixture of compounds in individual components. To identification and separations of mixture of components into individual components by using finely divided solid liquid spread over a glass plate and liquid as a mobile phase. It is used to identify as separations of mixture of components into individual components. That is called the thin layer chromatography. It is developed by two scientists. TLC is based on the principle of adsorption chromatography. Paper chromatography also based on the principle of adsorption chromatography. In thin layer chromatography also same chromatography principle. Adsorption chromatography. The movement occurs in such a way that a compound which have higher affinity to the stationary phase moves slowly while the other compound travels fast. Therefore, separation of mixture is attained. On completion of the separation process, the individual components from the mixture appears as spot on a plate. This is the principle. In detail we see the principle means it is based on the principle of adsorption chromatography. On the chromatography plate and one or more compounds are spotted on the thin layer of the adsorbent. Through the capillary action, the mobile phase solvent passes through the TLC plate. The component which is having lesser affinity towards stationary phase travel faster. The component which having more affinity towards stationary phase travels slower. This is the principle of the thin layer chromatography. In thin layer chromatography, basic operations involved in TLC that are: first one, method for production of the thin layer plates. Second one, application of sample on chromato plates. Third one, choice of adsorbent. Fourth one, choice of solvents. Fifth one, detecting reagents. Sixth one, developing chamber. These are the basic operations involved in TLC. In TLC, the procedures involved that are: first we select the stationary phase adsorbent. Adsorbent is select first. A stationary phase which has good absorption of given sample is selected. The selection depends on the chemical composition of stationary phase. The TLC of stationary phase adsorbent is coated onto a thin sheet of glass, plastic and aluminium as a thin layer, about 0.25 mm thickness. The sample is spotted on this plate. The mobile phase is allowed to run through this plate, and after development of plate, the RF value for each solute is calculated. The RF value is most important factor for identification of sample. Sample will identify by using the RF value. RF means retardation factor is equal to distance travelled by solute from the baseline by distance traveled by solvent from baseline. Second point is selection of mobile phase. Selection of mobile phase is the most important parameter to achieve efficient separation by TLC. The selection is based on sample solubility in mobile phase. The normal phase chromatography, when nonpolar solvents such as hexane or pentane are used. Non-polar compounds will move up the plate while most polar compounds stay on the baseline. The polar solvents allow polar compounds to move up the plate. What are the solvents with polarity index means? Water, acetic acid, acetonitrate, ethanol, methanol. These are the solvents with the polarity index. Third point of the procedure TLC is preparation of TLC plate. Various methods of preparing layers are in the TLC plate is prepared by various methods. One is pouring, dipping, spraying, spreading. The applicators are used for preparation of TLC plates. That is what are the methods in preparing for TLC plate that will be seen later. Fourth point, sample application. A microsyringe is generally used for transferring the sample solution to the thin layer of the quantitative work. The solvent used for sample solution should be volatile and as non-polar as possible. Fifth point, development tank. Ascending chromatography is most common technique in DLC. The plate is placed in a development chamber. The bottom of the chamber is covered by solvent. Three sides of tank are lined with solvent impregnant paper while top is covered tightly with lid. And sixth point, detection. The common will be detected. Seventh one, the evaluation of the chromatogram. After the detecting separated solute on the plate and marking their position, the evaluations may be either qualitative or quantitative. This is the procedure for the TLC, thin layer chromatography. Next we see the preparation of sample, preparation of TLC plate technique. That are five preparation method. One is pouring, dipping, spraying, spreading per coated plates. This is the process. First one pouring, at dipping. Third one spraying and spreading and pre-coated. This is the structure of TLC. First see the briefly about the preparation of thin layer chromatography. First one pouring. Pouring means the slurry prepared and poured on into the glass plate and is spread uniformly on glass plate after setting plates are dried in a oven. That technique is pouring. Dipping means the two plates are dipped into slurry and separated from after removing from slurry and dry. That technique is called dipping. Third technique, the third technique is spraying. Spraying means this technique is like perfume spray on cloth. The slurry is sprayed on a glass plate using sprayer. Fourth one, spreading. Spreading means TLC spread. It is also known as TLC spreader. The slurry is poured inside the reservoir of spreader. The spreader is rolled only once on the plate after setting the plates are activated by the keeping in an oven. That is called spreading method. These are the preparation of thin layer chromatography. What are the advantages of the TLC and disadvantages? First one, advantages of the TLC. First advantages is require large preparation scale is required. Second one, it is applicable, almost all chemical compounds will be applicable by using the thin layer chromatography. The other advantages are less equipment is required and low cost, no instrumentation is required, it is more sensitive. These are the other advantages. Next, we see the disadvantage of TLC. Thin layer chromatography plates do not have longer stationary phase. It do not have the longer stationary phase. That is the one of the disadvantages of TLC. Next one, the results generated from TLC are difficult to produce. The result is generated difficult to generate. This is the second disadvantages. The third type of chromatography is gas chromatography. Now we see the gas chromatography. First we see the introduction part. Gas chromatography means a technique used to separate volatile and polar molecules. It is used to separate the volatile and polar molecules. Volatile means ability to vaporize, that is called volatile. The volatile example for chloro oil is the example for the volatile molecules. The components of gas chromatography is analyte, volatile molecule sample, mobile phase, gas, helium, nitrogen, etc. Stationary phase we use the liquid and solid, silicon, grease or wax. These are used in the stationary phase in gas chromatography. The mobile phase gas, stationary phase liquid, solid. In gas chromatography, the two types of columns used. One is packed column, second one is capillary column. In gas chromatography, the sample injector and column is enclosed in a oven and increased temperature up to 400 degrees Celsius. Elevated temperature is used for the temperature programming. Next, we see the principles of gas chromatography. In this gas chromatography, we do the volatility is increased, no interaction with the stationary phase, and it moves faster. And the volatility is sometimes the volatility is decreased. The more interaction with the stationary phase and moves slower. If volatility is same, the non-polar means don't interact with the polar, so stationary phase moves faster. The polar means react with the polar, stationary phase moves slower. This is the principles of gas chromatography. Next, we see the instrumentation of gas chromatography. In gas chromatography, this is the picture of the gas chromatography. In this picture, what are the parts included in the gas chromatography means, first we see the carrier gas, gas flow regulator, sample, injector spot, column, oven, detector, waste, computer and data analysis these are the parts included in the gas chromatography. Next, we see the instrumentation. Include carrier gas, sample injection system, column, detector. What are the detectors we used in gas chromatography means thermal conductivity detector, flame ionization, electron capture detector, nitrogen phosphorus detector, flame photometric detector. These are the detectors used in the gas chromatography. See by one. Procedure. First, we in a carrier gas. First one, carrier gas. The hydrogen, helium, nitrogen, and air are most widely used for the carrier gas. Hydrogen is compression to other gases is more advantageous and also dangerous to use. Helium is best gas. It is used because of its exceptional thermal conductivity, inertness, low density and greater flow rates, but it is expensive. Nitrogen is inexpensive but reduced sensitivity. Second one, sample injector. A system of sample injector is used for introducing the sample in a reproducible manner and vaporize it rapidly so that the sample enters the column as a single slug. The liquid samples are reduced into small inlet chamber used in hypodermic syringes through a self-sealing rubber septum. The chamber is heated to cause flash evaporations and temperature should not be very high to avoid sample decomposition. Third one, separation column. The column is used as made of glass or metal tubbing and have a diameter 4.8 millimeter. They may be any length ranging from a few centimeters to 100 meters. They may be coiled, bent or straight. 6 types of analytical columns are used in gas chromatography. They are packed column, open tubular or capillary or colloid column, supporter coated open tubular column, fourth one wall coated open tubular column, porous layer open tubular column, supported coat open tubular column. These are the columns we used in the gas chromatography. Next, detectors. There are various detectors used in gas chromatography. Gas chromatography employs a wide range of detectors, of which flame ionization detector, thermal conductivity detectors are most common ones. Thermal conductivity detectors see briefly. These detectors utilizes a heated filament placed in a emerging stream. The thermal conductivity of the gas phase governs the amount of heat the filament loses by conduction to the detector wall. The temperature depends on thermal conductivity of surrounding gas. The hydrogen and helium have higher thermal conductivity and carrier provide best sensitivity. This is known about the detector, thermal conductivity detector. In thermal conductivity detector, structure consists gas flow in, filament, gas flow out, and block section. Next, the readout is mentioned in gas chromatography. In short procedure the short procedure of gas chromatography. First, open wall gas flow forward. There is a flow controller. Throw sample inlet. Sample is introduced. The sample convert gas. Then only analyze the sample. Then gas go with the mobile phase and election take place. Sample inlet and column enclosed in chamber, which is oven. Increase temperature of oven. Next step, the detector will detect the sample, then give signal to recorder. The recorder gives peak of the sample. Next, after elution, sample will go the detector and record it. The shapes of the column: straight is small size, U shape slightly higher, coiled very long column. These are the shapes of column. Next, chromatography see before it we see the advantages. Advantages of gas chromatography are: first one, separations of organic compounds. Second advantages, fast, separative and reliable technique. Both quantitative and qualitative analysis can be done by gas chromatography. Fourth one, high sensitivity. Next, low cost, rapid analysis, improve resolution, high accuracy and precision. It requires small sample doing the gas chromatography. What are the disadvantages of gas chromatography? Are: first one, sample used to be poor. Second disadvantages, need skill to handle. Third one, biosamples cannot be analyzed. Fourth one, not suitable for thermally layable samples. These are the advantages and disadvantages of gas chromatography. Next, we see the application of gas chromatography. They are: determine the quality of air, identify. Second application is identify potentially harmful chemical in air. Third one, qualitative analysis. Fourth, quantitative analysis. Fifth one, to separate the fatty acid from fixed oil. Next application, inorganic compound analysis. It is used in food, beverages, flavor and fragrance analysis. It is used in environmental analysis, and it is used in detection of body fluid. These are the advantages, disadvantages, application of gas chromatography. And the last chromatography we see The last chromatography is HPLC. HPLC means high performance liquid chromatography. Is an analytical technique used to separate, identify and quantify the pictures. It gives high performance due to smaller particle size of stationary phase. High pressure is applied for rapid separation of compound. There are two phases, mobile phase and stationary phase are used in HPLC. HPLC briefly expand high performance liquid chromatography. In HPLC, other names are, it is also known as high pressure liquid chromatography and high price liquid chromatography. This chromatography is very high price. What is the definition of HPLC means? It is a chromatography technique used to separate components of mixtures of the purpose to identify, quantify and purify the individual components of mixtures. It is used in field of biochemistry, analytical chemistry. Components of HPLC means analyte sample, stationary phase, polar hydrophilic liquid or sample, silica, mobile phase, non-polar liquids. Example, water and methanol we use. Next we see the types of HPLC. Now, first one, normal phase chromatography. Second one, revised phase chromatography. Third type, size election exclusion chromatography. Fourth type, ion exchange chromatography. Fifth type, affinity chromatography. These are the types of HPLC. Next we see the principle. It is based on polarity. If a polar molecule, the main principle involved in HPLC is adsorption. This day we see the paper chromatography, gas chromatography, HPLC. These all are based on the principle adsorption chromatography only. If the polar molecule don't interact with the non-polar stationary phase, moves faster. And if a non-polar molecule react with the non-polar stationary phase, moves slower. Purification takes place in the separation of column between stationary and mobile phase. If the stationary phase is a solid, based on adsorption chromatography. If the stationary phase is liquid, the principle is based on the partition chromatography. And next we see the instrumentation of the HPLC. This is the structure of the HPLC. What are the parts? Parts are solvent, pump, injector, HPLC column, detector and a waste carrier. Instrumentations are solvent reservoir, degasser, vacuum pump, solvent mixing ball, HPLC pump, curd column or pre-column, sample injector, analytical columns. These are the instrumentation of HPLC. What are the detectors we used in HPLC? Are first one, optical detector. It contains fixed wavelength, variable wavelength. Second detector, differential detector. Third detector, electrochemical detector. Fourth, mass spectrometer. Fifth, fluorescence detector. These are the detectors we used in HPLC chromatography. Short procedure of the HPLC. First, the pump have in the HPLC. The rate of pump is to force a liquid called mobile phase into the column at a specific flow rate expressed in ml per minute. The normal flow rate in HPLC is 1 to 2 milliliter per minute. Types of pump: constant flow reciprocating pump, syringe type pump and pneumatic pump. Second one, mixing unit. The mixing unit is used to mix solvent in different preparation and pass through the column. The mixing of solvent is done either with static mixture, which is packed with beads, and dynamic mixture, which use magnetic stirrer and operates under high pressure. Third, third step, solvent degassing. Several gases are soluble in organic solvents. When solvents are pumped under high pressure gas, bubbles are formed which will interfere with the separation process, steady baseline and shape of peak. Hence, degassing is necessary. The techniques for solvent degassing are vacuum filtration, helium purging, and ultrasonic. These are the techniques we used in solvent degassing. And fourth step, injector. The injector serves to introduce the liquid sample into the flow mobile phase. The typical samples volumes are 5 to 20 microliters. The injector must also be able to withstand the high pressure of the liquid system. The type of injector used in the HPLC, that is septum injector and stop flow injector. These are the injector we used in the HPLC sample injectors. Fifth step is column. The most important part of the chromatography, column. The column length varies from 5 to 30 cm. The column diameter ranges from 2 to 5 cm. The particle size of the column 1 to 20 micrometer. The particle nature of the columns are it is spherical, uniform sized, porous materials are used. The sixth step is detector. The detections of separated components in a elute from the column is based on bulk. First one is bulk property of elute. Second one, solid property of individual. The detector should respond to a particular property of the substance being separated, and it should be sensitive to at least at 8 raised to minus 8 gram per milliliter and give a linear response over a wide range concentration range. The most commonly used detectors are high-speed detectors are photometric detector, fluorescence electrochemical detector, refractive index detector, and read out the value in graphical representation. What are the advantages of HPLC means? Advantages: it is simple and rapid and reproducible, and high performance is included, and high sensitivity. It is a rapid process, and it is time consuming process, and it is high separation capacity. The stationary phase or mobile phase is chemically inert. These are the advantages of the HPLC. These are the advantages, instrumentation and principles of the HPLC. This day we learn about the chromatography, definitions, types and techniques, detectors that are used. What are the types of the chromatography we see? First one, paper, gas, TLC, HPLC. Chromatography, instrumentation, principle, advantages, disadvantages, applications. Thank you.